So we'll start with the chapter Relations and Functions. In today's class, we'll be learning about relation, and from the next class onwards, we'll be learning about functions. So to begin with relation, the first topic under this is a ordered pair. So what is an ordered pair? Two numbers A and B listed in a specific order and enclosed in parentheses form an ordered pair A comma B. So say 2 comma 3. So while we make graph, how do we mark 2 comma 3? Say 1, 2, 3, 1, 2, 3. So 2 comma 3, x-axis we take point 2 and y-axis we take 3. So this point we say is 2 comma 3, where 2 denotes the point in the x and 3 denotes the point in the y. And 3 comma 2, we have x-axis 3 and y-axis 2. So this is our 3 comma 2. And clearly we can say that 2 comma 3 and 3 comma 2 denotes two different points. So 3 comma 2 and 2 comma 3 is not equal. So this is what an ordered pair is, where order matters. What you write first and what you write second matters. So 2 comma 3 like 3 comma 2, they are unequal. Okay. So next point, how can we say that two ordered pairs are equal? So equality of two ordered pairs. So if A comma B is equals to C comma D, this by implies that A equals to C and B equals to D. By implies means if A comma B is equals to C comma D, then A comma C will be equal and B will be equals to D. And if B is equals to C and B equals to D, then we can say that A comma B equals to C comma D. Basically the first coordinate will be equals to the first coordinate and the second coordinate will be equals to the second coordinate. Next topic is a Cartesian product of two sets. Let A and B be two non-empty sets. Then the Cartesian product of A and B is the set denoted by A cross B, consisting of all ordered pairs A comma B such that small a belongs to capital A and small b belongs to capital B. Therefore, if we write it mathematically, A cross B will be equals to the set of A comma B such that the first element A comes from the first set A belongs to A, and the small b, the second element, will come from the second set, B belongs to capital B. This is our definition for Cartesian product of two sets. And in definition, we took that A and B are non-empty. So what if A or B, one of them is empty? So if A is equals to 5 basically means an empty set, or B equals to 5, we define A cross B is equals to also 5. You need to note over here 2 points. First point, if number of elements in capital A is say P and number of elements in capital B is Q, then the number of elements of A cross B will be equals to PQ, and also of number of elements in B cross A will also be equals to PQ. And second point, if at least one of A and B is infinite, then A cross B is also infinite, and B cross A will also be infinite. Last topic for this under ordered pair is our ordered triplet. After this, we'll see some examples and then we'll begin the main topic, that is relation. So, ordered triplet. So, what is an ordered triplet? Three numbers A, B and C listed in specific order and enclosed in parenthesis. Parenthesis is basically the first bracket, this round brackets that we use form an ordered triplet, like A, B, C. Also, we need to remember that the order must be specific, that is 1, 2, 3 will not be equals to 2, 3, 1 and is also not equals to 3, 2, 1. You can take any order. If you change the order, then they are unequal. So, for any non-empty set A, we define A cross A as the set containing small a, small b, small c, such that small a, small b, such that small a, small b and small c, all three comes from the set A. Next, we are going to solve some problems relating them. If x plus 1, y minus 2 is equals to 3, 1, find the values of x and y. Solution. So what is an ordered pair? In equality of ordered pairs, we saw that if A, B is equals to C, D, then A will be equals to C, the first element equals to the first element, and B equals to the second element equals to the second element. So over here, x plus 1 comma y minus 2 equals to 3 comma 1 implies that x plus 1 equals to 3 and y minus 2 equals to 1. So this implies x equals to 2 and y equals to 3. So these are the values of x and y. Second question. If P is a set containing A, B, C and Q is the set containing say R, form the sets P cross Q and Q cross P. So P cross Q, so A cross B we saw is the set containing A, B, where the first elements come from the first set and the second elements come from the second set. So P cross Q will be equals to first element coming from the first set, second element coming from the second set, A, R, B, R, C, R. There are no other elements possible, so this is our P cross Q. And Q cross P will have the first element coming from Q. So this will be R, A, R, B, R, C. This is our P cross Q and Q cross P. Third question. Let A is equals to 1, 2, 3, B equals to 3, 4 and C is equals to 4, 5, 6. Find number 1 A cross B intersection C. Number 2 A cross B intersection A cross C. Number 3 A cross B union C. And number 4 A cross B union A cross C. So solution. So for the first part, what we need is B intersection C. So B intersection C is equals to the elements that is common in B and C, that is only 4, singleton set 4. So A cross B intersection C will be equals to 1, 4, 2, 4 and 3, 4. So this is our A cross B intersection C. For both of this, what we'll need is A cross B and A cross C. So let's find A cross B and A cross C. So say A cross B will be equals to 1, 2, 3 and 3, 4. So 1, 2, 3, and second set we had 3 and 4. So we put 3, now we put 4. So this is our A cross B. A cross C will have 1, 2, 3 in A, and in C we have 4, 5, 6. Four, 5, 6, 4, 5, 6, 4, 5, 6. Okay. Now for the second part, we have A cross B intersection A cross C. So intersection will contain elements that are common. So 1, 4, 2, 4, 3, 4. Only these 3 elements are common. So 1, 4, 2, 4 and 3, 4. For the third one, we have A cross B union C. So let's find B union C first. B contains 3 and 4 and C contains 4, 5, 6. So B union C will become 3, 4, 5 and 6. So A cross B union C is equals to A has 1, 2 and 3. There are 4 elements, we'll make this 4 times. So 3, 4, 5, 6. 3, 4, 5, 6. 3, 4, 5, 6. And the fourth part, we have A cross B union A cross C. So we have A cross B and A cross C. We'll take the union. Union means we'll take all the elements that are there, including the common ones. So 1, 3, 2, 3, 3, 3. 1, 4, 2, 4, 3, 4, 1, 5, 2, 5, 3, 5, 1, 6, 2, 6, 3, 6. So this is how A cross B union A cross C. If you notice, then A cross B intersection A cross C is same as A cross B intersection C, and A cross B union C is same as A cross B union A cross C. Okay, next question. So this was our number 3. Number 4. If P is equals to 1, 2, form the set P cross P cross P. In order triplet, what did we take? Is that we took 3 elements, all 3 coming from A, and we took different formats. So in solution, we'll have P cross P equals to, we'll take all the different arrangement that is possible with these 2 elements of P. So 1, 1, 1, 1, 1, 2, 1, 2, 1, 1, 2, 2, 2, 1, 1, 2, 2, 2, 2, 2, 1 and 2, 1, 2. These are all the possible arrangement that is possible. So we have all these elements in our set. Number 5th one. If R, this is our set of real numbers, is a set of all real numbers, what do the Cartesian product R cross R and R cross R represent? Okay, so solution. So R cross R is basically, say, like, take this as a real number line. So if this is a real number line, this is the another real number line. So R cross R will give all the points that are in between them. So when we take R cross R, we basically get the whole 2-dimensional plane. So R cross R basically represents the x-axis and the whole of y-axis. So with x-axis and y-axis, what we get is the whole two-dimensional plane. So r cross r represents the two-dimensional plane, and r cross r represents, in a similar way, what happens is r cross r is two-dimensional plane, and a third multiplication with r will give us the third axis, that is the z axis. So r cross r represents the three-dimensional plane. Three-dimensional plane is basically the whole space that is around us. Number 6. If A cross B is P comma Q, P comma R, M comma Q, comma M comma R, find A and B. So we know that the first elements come from the first set, that is A. So A will contain P and M, and the second elements come from the second set, that is B. So B will contain Q and R. So with this we come to the end of ordered pairs. Now we'll begin with relations. So the topic, relation. So what does a relation? How do we define a relation? Let A and B be two non-empty sets then a relation R, we are naming the relation as R, from A to B is a subset of A cross B. If we take the Cartesian product A cross B, and whenever we take any subset of A cross B, basically we get a relation R from A to B. Thus, R is a relation from A to B basically implies that R is a subset of A cross B. It may be proper, it may be equals to A cross B, hence we write this subset. We do not remove this equality sign. It may be equal or it may not be equal. If A comma B belongs to the relation R, then we say that A is related to B. This is the exact statement that we say, A is related to B, and we write A relation B. And second point, if A comma B is not belonging to the relation R, then what we say is A is not related to B. And we write A not related to B. Next we have the definition for domain, range and codomain of a relation. So let R be a relation from A to B. Then the relation R is basically a subset of A cross B. So first, the set of all first coordinates of elements of the set R, that is A cross B, relation R, that will be a subset of A cross B, is called the domain of R, written as domain of R. The second part, the set of all second coordinates of elements of R is called the range of R. Denoted by range of R. And the third definition, that is the codomain, this set B, A cross B, the second set is basically called a codomain. The set B is called the codomain of R. Domain of R is basically equals to A, such that A comma B belongs to the relation R. So whenever A comma B belongs to relation R, all the first elements when we take from the relation R, this is basically the domain, and a range of relation R is basically all the elements, second elements, that is the element B, where A comma B belongs to the relation R. Note, let's say in A cross B the number of elements in A is P and the number of elements in B is Q. And then the number of elements in A cross B is equals to PQ. We saw this earlier. We know that every subset of A cross B is a relation from A to B. Relation is basically a subset. So any subset that we take of A cross B will become a relation from A to B. So the total number of subsets of A cross B will be equals to 2 to the power PQ. This we have seen in the chapter sets, where we discussed that if there are m elements in a set, then the total number of subsets will become 2 to the power m. So here A cross B has number of elements PQ, so the total number of subsets of A cross B will become 2 to the power PQ. So what is relation? Relation is basically a subset of A cross B. So the total number of subsets is basically the total number of relations of A cross B. So the total number of relations from A to B is equals to 2 to the power PQ. So we'll solve some questions relating them. Okay, we'll also see how we represent this graphically. Let's deal with a question to see how we deal with it graphically. So last question we did was 6. Next we'll do 7. let A equals to 1, 2, 3, 4, 5, 6. Define a relation R from A to B A to A by R equals to x comma y such that y equals to x plus 1. Number 1, depict the relation using an arrow diagram. We'll see how to make an arrow diagram. And number 2, write down the domain, codomain and a range of R. So solution. Okay. So x comma y says that y equals to x plus 1. So first element and the second element should be 1 greater than the first element. So we'll have R equals to 1 comma 2, y equals to x plus 1, 2 comma 3. The maximum value that we can take is 6. So we'll go till 3 comma 4, 4 comma 5 and 5 comma 6. This is a relation from A to A, means the second element can only come from A. If we take x as 6, so if we take the first element as 6, the next element will become 7, which will not be possible because 7 is not there in A. So this will start with 1 comma 2 and go till 5 comma 6. So this is our relation. For the first part, we are depicting this in using an arrow diagram. In arrow diagram, what we do is we make a like this, an oval shaped, where we write in the first one, we write all the set that is there in codomain. Domain. So A, we have 1, 2, 3, 4, 5, 6. So we have the set from A to A. So second also we'll write A, 1, 2, 3, 4, 5, 6. Now 1 is related to 2. So 1 goes to 2. 2 goes to 3, 3 to 4, 5 to 6. So this becomes our arrow diagram. This is A, this is A, this is our relation defined by R. And for the second part, write down the domain. So domain is basically all the elements first that is there in the first one. So our domain will become 1, 2, 3, 4 and last element is 5. That is there in the first one of the ordered pair. Range is the elements. Range is basically the elements of the second element in this ordered pair. So all the second elements when we take from the ordered pairs, we get the range. That is 2, 3, 4, 5 and 6. And codomain is basically in A cross B, the codomain set P becomes the codomain. So here in this question we are taking relation from A to A. So A becomes our codomain. So codomain is equals to the set A, which is equals to 1, 2, 3, 4, 5 and 6. Basically this whole set that we have in the right side is our codomain. Number 8. The figure below shows a relation between P and Q write the relation. Number 1, in set builder form. Number 2, in roster form, and what is its domain and range. Solution. Okay, the diagram first. So in first diagram we have 9, 4 and 25, and in the second one we have 5, 3, 2, 1, minus 2, minus 3, minus 5. 9 is related to 3. This is our quotient, and 9 is related to minus 3. It's given in the quotient. 4 is related to 2 and 4 is related to minus 2. 25 is related to 5 and 25 is also related to minus 5. So first part, what we need to do is we need to write the relation in set builder form. So first part, solution. In set builder form, how we'll write this is relation R will be equals to x comma y such that, as we can see here, x comes from this set P. This is our set P, this is our Q, such that x belongs to P, comma y belongs to Q, and we see that this x is the square of y. So x equals to y square. 3 square 9 minus 3 square 9, 2 square 4 minus 2 square 4, 5 square 25 minus 5 square 25. We didn't have a 1 anywhere, so x is equals to y square. So this is our relation in set builder form. Second part, we need to write it in roster form. So in roster form we have 9x comma 3, 9 comma minus 3, 4 comma 2, 4 comma minus 2, 25 comma 5 and 25 comma minus 5. These are all our elements that is there in the relation R. And what is the domain and range? So domain, the first elements that we see are the domain. So domain will be equals to 9 comma 4 comma 25, and range, all the elements that is there in the second element of the ordered pair, that is 3 comma minus 3 comma 2 comma minus 2 comma 5 comma minus 5, and this will be our range. And last question, let A equals to 1 comma 2 and B equals to 3 comma 4. Find the number of relations from A to B. Solution. So number of elements in A cross B will be equals to 2 into 2, that is 4. So therefore number of relations from A to B will be equals to 2 raised to the number of elements in A cross B, that is 2 to the power 4, which is equals to 16. So this will be the total number of relations that is possible from A to B. With this we come to the end of this lecture. Please solve the first and second exercise of NCERT as your homework. Thank you.